So let us look at some examples. On this page you will see a few dots labeled A, B, C, D, E, F, G and H, and the dots are very large. If I would indicate the point on that coordinate system, you would almost not see it, so small will it be, but we make it larger so just to make it more visible. So I've written down all the coordinates there with the x's in ascending order. So A, we have -4, 2, B is -3, 4, C is -2, 2, etc. Until you have H, which is 4, -5. So what is the domain then of this set Q? We call Q the set of A, B, C up to G, up to H. You call that set. So first of all, we see these are discrete values, so we need curly brackets, and we can just list them: -4, -3, -2, -1, 0, 2, 3, and 4. And since there are no number 1 here, there's nothing here where x is equal to 1, we can't make it easier there. We just have to write out each and every one of that. The range will be all the y values or all the second coordinates. These are the first coordinates. If we look at the range, we see that now we look at the second coordinates and we can list it: first, 2, 4, 2, 6, 3, 6, -2, and -5. But whenever we have a set like this, we never repeat values. So first of all, we will not use the second 2, we will not use the second 6, and then it looks much better when we also write it in ascending order. So the smallest number that we have is -5, then the next one looks now -2, and then we get to the number 2, and then 3, and 4, and 6. So in some cases, we have used the second coordinate, or the sum of the numbers we use, more than once, but each x value has its own y value. There are no duplicates here, so this is still a function. So this is all the second coordinates. So we start by listing that. You can list it on your rough work or whatever, and then you write it down neatly. So this is our range. So WQ will be that. The function that we have here is a piecewise defined function. We have f of x, so this part here from -6 up to -3 is the function f. The next part from -3 up to 4 is the function g, and the next part from 4 to 7 is the function h. Now we have to write down the domain. So in this case we have a continuous function. It is not a smooth function, but it's continuous because it keeps on here. If it's actually, this is wrong to have both of them equal to -3, so let us just remove the 1 -3 here. It will not change the graph though, because the one hole will fit on the other dot. So then the domain of this function will be, and we can start with it like this. We can say, okay, the first part is from -6 up to -3, and that's an open bracket, and then we have a close bracket up to 4, and then we have an open bracket 4 up to 7, and we also discussed this union sign in the chapter 1. But because there are no breaks in these lines, although it has sharp edges, we can write that as from -6 up to 7, but 7 still has to have a round bracket. Now let us look at our range. For our first part, for f, we will have from 1 to 4. And since we changed it there to the -4, so this will be an open bracket there, then union from 4 close bracket to 7 close bracket, and then from -4, which should be open, up to 7. So in this case, the first part we can write as a union. You can say this is from 1 to 7. That part there is from 1, all the vertical. You can take your ruler and go up, until you don't touch the graph anymore. So from 1 to 7 are all connected, and in this one is from -4 to 7. So if you put from -4 to 7, then in actual fact, when we combine it, we will get the answer of the smallest number, which is -4, and the largest number, which is 7, but 7 is included. By just taking a ruler, if you take a ruler, a horizontal line, and you just go up with this ruler here, horizontal, and where you don't touch the graph anymore. So it's from -4 to up to 7. Here, although the function doesn't overlap, it doesn't matter. So we can have all these values from -4 up to 7. Remember, union is always bigger than intersection of normally it's bigger.